In this video, we're going to take a closer look at major components that make up a computer system. So, for example, one of the core parts of a computer system is the processor. Okay, uh, so so the processor, sometimes also called central, for central processing unit. Now, many times this is a single chip. It could be multiple chips that make this up, depending on if they need some helper for certain functions. One of the common one is if you're playing a lot of games, you need a lot of floating point multiplication and division, and they create a math coprocessor that you could sometimes also called, sometimes that's included in the graphics coprocessor that they add to it. But for the time being, let's collectively call all the stuff, all the hardware that is used to decode the binary codes to know what needs to happen, call it CPU. So that was one major component. Then the other major component is memory. And we're going to spend a little bit more time on memory because not all memories are the same. There are all variety of memory, and we need to spend a little bit of time understanding the memory portion of it. Then there are some glue circuitry, simple logic or more complex logic, which ties the processor and the memory together. Another big hardware block in any computer system is, of course, the I/O, or the input output section. And to get a sense of what they are, if you ever look at a standard computers or what we are calling desktop computers or laptop computers, you'll see on the back of them, you will see some connection for a local area network or networking, and as a broad term. Another networking thing you will see on the back of it might be a USB. Some of the unseen versions of this on the back end, because they use wireless, is for the LAN. Sometimes we have Wi-Fi, which we don't see, and then Bluetooth, which we may not see as well, but we can make connections and use it as an input and output. And some of the more common ones, such as a mouse or some pointer devices, keyboard, and for example, touch screens and things like that. Oh, and then screens, of course, display interfaces. Each one of these have a variety. For example, display, depending on what you're looking at, in some cases you might have, there are multiple standards for each one. For example, a display, you may have a VGA type, usually associated with older machines. You may have HDMI or a slew of other types, but these are probably the most common one that is out there for you to have. The other one that kind of lived for a little bit, it is still on some of the systems, called DVI. But anyway, these are kind of the various, and this makes up. These are the major components you will find on a computer. So let's talk about this memory, or in a broader term, storage devices, because we got to kind of spend a little bit of time talking through that. The memory, it can be broken down basically based on how fast and how large and how it's accessed. So memory or storage, a more general term for it. Each one of these, we can break them up in many different ways. But I think memory and storage, the simplest way to think about it is a primary versus another type we'll call secondary. Okay. And the way computers work, although that is changing very, very rapidly also, but the way computers work is they have two types of memory, primary and secondary. Typically, the the cost per bit. If we call cost per bit, if the cost per bit is 1 unit, whatever unit, let's call it $1 for lack of a better term. The cost per bit down here for the secondary one is going to be 1/100 of whatever that unit was, or even 1/1000. So obviously it's a lot cheaper on the secondary. So why don't we do everything in secondary? Well, nothing comes for free. This typically the secondary memories are 1,000 times or 100 times slower than the primary memory. It has a range on it. So that's one of the big things that we need to consider, so let's talk about another. So usually these are large, like a typical PC today. You may have 1 terabyte, okay, which is about equal to 1,000 gigabyte, okay. And the cost, I don't know, the varies, but definitely under $100 today. Today being 2017, and then over here, primary memory, you may look at, typically 4 to 8 gigabyte is a common amount in here, although primary memories have all kinds, but let's say 8 gigabyte, and that it again is well under $100 as well. So you can kind of see the ratios here is not quite 1/1000, but it's getting pretty darn close. 1/100 in this case, 120, 130. So primary memory is where the processor, the reason it's called the primary memory is because the processor can directly access that memory and get the information it needs. The stuff that is in the secondary memory first has to be transferred to primary memory, typically before the computer can access it. Okay? So let's take a look at a primary memory. Primary memory may be volatile, the volatile, or of course the other side is non-volatile. And what that basically means is when I shut my computer off, is the memory stuff in the memory stays around or not. On the volatile types, when the memory is gone, it goes away. In the non-volatile case, is when the memory goes away, when the power goes away, the data doesn't go away. So data exists after power, data does not exist after the power, okay? So that's the volatility portion of it. Now in here, these are mostly dynamic random access types. So they're abbreviated dynamic random access memory, which basically means dynamic means you got to refresh them all the time. Power has to be on and you got to take care of them. But the RAM portion is random access memory, which basically means I can read any location and it will take me the same amount of time. Like in the olden days or on the secondary, you might have a tape drive. On the tape, you have, if you're reading it where your head is on the tape, you're done. You read it immediately. If your data is way down the road, you got to rotate the tape to get to where the data is before you can read it. So that's the random access portion of it that comes into play. Fast memory, expensive. Secondary memory, slower memory, but much cheaper. Okay. So non-volatile, we have memories that can keep the data after the power is gone. Some of the parts have names. ROM, you might have heard of. You might hear the word. Actually, the one we use pretty commonly here is the flash drive or the flash RAM or the non-volatile RAM. Those are some examples of that. And then the volatile portion, because as you want faster and faster the memory, more expensive it becomes. Sometime in some computers you have something called a cache memory. Usually it's a small amount of cache. These are usually like, let's say 1/100th of the memory, the volatile memory, primary memory is cache. They're expensive, but they're really, really fast, which means if you got a small amount of data that you can keep accessing from the processor, they'll pull it into the cache and use it out of the cache so the computer runs faster. And then main memory, typically they just call it DRAM. And this, sometimes the cache are what they call static RAM, or just a different kind of design, a static RAM, as opposed to a dynamic RAM, which basically means we don't have to refresh it, we don't have to take care of it, and they are bigger transistors so they can respond faster. They take more power, they're more expensive, but they're faster. So pretty much in decision of which memory type you use has to do with how much you're willing to pay, how much memory do you need, and what are you going to use it for. So we talk about secondary memory. Typically, like, we can consider hard drives, which are magnetic, or lasers, CD-ROMs of different types. All of those could be considered secondary type memory for backup, for storage, for putting your program there until you need it, things of that nature. So even USB jump drive, the low flash drive we use, could be considered it is considered secondary memory, because the program cannot execute out of there. It's got to be brought into either the static RAM, which is the cache, or the dynamic RAM before it can be used. Okay. So how we decide what we use is we basically trade off price versus speed. That brings us to the end of this section, kind of giving you an overview of what a central processing unit is and what are the different kinds of memory.